Okay, let's do it. So let's find the derivative for y equals 3x cubed plus 2x squared to the fourth power. So I'm not going to give you time to do it because that will take a lot of time to wait for every problem. But a quick review here. What we need to do is we can use the chain rule. Bring the 4 down. Keep this the same. Subtract 1 from the top times the derivative of this part. Keep this the same. This is 9x squared plus 4x. And you can leave it like this. Easy peasy. Find y double prime for y equals cosine square x. Again, chain rule. So y prime, you bring the 2 down, subtract 1 from the 2 times the derivative of this. Now I brought the 2 down and subtract 1 times the derivative of the circled part. Then y prime equals 2 cosine x stays the same. The derivative of cosine is negative sine. So y prime, bring the negative out. 2 cosine x sine x. That would be an answer. Or keep in mind, if you can notice the 2 sine cosine, that's sine 2x. So either one would be fine. So you can write it this way or that way. Now, I'm going to go with the second one because it's easier to differentiate this than the one above it, the boxed one. So now we can find y double prime. Y double prime, keep the negative out. The derivative of sine u, it's u prime cosine u. Anyone has any question about this? If so, in the chat, please. All we have been using here, the chain rule, applications to the chain rule. Find the derivative dy dx if x squared y plus xy squared equals 2020. So this reminds us about implicit differentiation. And I'm going to use the product rule. The derivative of x squared is 2x times y plus x squared y prime. That's for the first one. Plus derivative of x is 1 times y squared plus x times the derivative of y squared equals 0. Now we need to find y prime. So keep x squared y prime the same plus 2xy y prime the same. You can subtract 2xy and y squared. Take y prime out. That will give x squared plus 2xy equals negative 2xy minus y squared. Then y prime equals negative 2xy minus y squared over x squared plus 2xy. That's what we need. That's what dy dx is. We can move on. Find the slope, just the slope of the normal line to the graph of y equals x plus sine xy plus 1 at 0, 1. So normal line is the line. So if you have a curve and you have a tangent line, this is the normal line, the line that is perpendicular to the tangent line. So this is tangent and this is normal. So we need to find the slope of the tangent line. So slope of the tangent line is the derivative at that point. So m of the tangent line is y prime at x equals 0. At x, this x. So what do we need to do first? Find y prime. So we can take that, differentiate both sides. Y prime is 1 plus, actually we don't need the plus 1 here. No, we need it, sorry, we need it. Y prime is 1 plus, what's the derivative of this? Is the derivative of xy cosine xy plus 0. So it's not done. Here we use the product rule, xy prime plus 1 times y cosine xy 0 comma 1. So substitute x0 and y1. 0 y1 cosine 0 times 1. So y prime would be 1 plus, this is 1. Cosine 0 is 1. 1 times 1, 1. So that's 2. So that's the slope of the tangent line. Then slope of the normal line, it's negative reciprocal, 1 over 2 with the negative. Okay, next one. Find the derivative for the function y equals the integral of secant 3x to 2020 the square root of 1 minus t squared dt. This is the one where we call it the second fundamental theorem of calculus. Very important. So to recall it on the side here, it says y equals a to a function f of x, g of t dt. Y prime is g of f of x times f prime of x, as long as a is constant. So what you need to do first is swap the bounds. Put the 2020 down as secant 3x up and keep this the same, dt. But when you swap the bounds, this becomes negative. Then y prime is the square root of 1 minus secant squared 3x times, there's a negative out, don't forget it, times the derivative of the secant 3x. It's not done because we still need to find the derivative of secant 3x. Derivative of secant u is u prime secant tangent. So secant 3x tangent 3x. And also 1 minus secant square is tangent square. And this comes outside as a tangent. and we can put the 3 out. Usually people put absolute value, but I'm gonna assume it's positive. So secant 3x, tangent 3x. And notice I have a tangent 3x repeated here and there. I can multiply them together, and y prime would be negative 3 tangent square 3x secant 3x. We have an absolute value integral from 0 to 2. There are several ways to do this. We can integrate this by graphing it. So we can graph, this is y equals absolute value of x minus 1. If you remember how to graph this, you can, plug in points x0, y1, x1, y0. x2, y1, and so it's going to be a V shape like this. They want us to find the area, because what this represents the area under the graph over the interval 0 to 2. So that's 2 here. So we need to find the area of this and the area of that. So the integral is going to be, this integral will be, the area of this is a triangle, 1/2, base is 1 and the height is 1. Plus the area of the other one is also another triangle, from 1 to 2 is 1, and this height was 1. So what do we get? 1/2 plus 1/2, it's 1. Recall, what's the integral of EX? Do you guys remember this? It's EX, right? This is EX. Don't forget the plus C. The integral of 1 over x is ln, or natural log of absolute value of x, plus C. Those are important to keep in mind. If we are asked to integrate x cosine x minus 3 all over x, and let's say plus x dx. Let's go over it now. The easy way to do this is to break it out like this. It will make it much easier. This becomes cosine x minus 3 over x plus 1. Then you can split this integral. Integral of the first one minus the integral of the second one plus the integral of the last one. The integral of this is sine x. Take the 3 out. Natural log of absolute value of x plus x. Don't forget the c. Try this one. We need the x, only the x coordinate of the inflection point of the function y equals 3x to the third minus 12x squared plus 18x minus 20. So to do such a problem, we find first derivative 9x squared minus 24x plus 18. And then the second derivative 18x minus 24. And you need to set that equal to 0. Then solve for x. 24 over 18. By 2 is 12, by 2 is 9, by 3 is 4, by 3 is 3. Find limit of sine 2x minus x squared over x as x approaches 0. If you pass the limit to this, you will get 0 over 0, which is indeterminate. Then what we need to do, we can use L'Hopital's rule. L'Hopital's rule is the derivative of the top, 2 cosine 2x minus 2x over 1. If you pass x to 0, that will give us 2 cosine 0 minus 0. 2 times 1 minus 0, so that's 2. For the second one, for this one, if you pass the limit as x goes to 0, you will also get 0 over 0. You can either rationalize or use L'Hopital's rule. Either one would be fine. If you want to rationalize this, you multiply by the conjugate. Top and bottom by 5 plus the square root of x squared plus 25. 5 plus the square root of x squared plus 25. This equals limit as x goes to 0. The bottom one stays the same. On the top is 5 squared, which is, it becomes like this, 5 squared minus this thing square. What do we get? Limit as x goes to 0. 5 squared is 25 minus, when you square the radical, that will clean up the radical sign. Keep this the same. Don't distribute this because we are hoping that it will cancel out. Then the limit as x goes to 0, 25 minus x squared minus 25. Keep the denominator the same. These cancel out. X squared cancel out. And then if you pass the limit on the top, you get negative 1. The bottom is 5 plus 5. So negative 1 over 10. Next problem, find y prime if y equals cosine x to the x power. This one I recommend you try. Let's do it. So to do this, there's no specific formula to help us find the derivative function raised to a function. So we have to use a natural log both sides. because natural logs, they have a power to allow us to bring the exponent down. So far, no calculus yet, just natural log both sides. Then implicit differentiation, then differentiate both sides. What do we get? Y prime over y equals, here we got two functions. Derivative of x is 1 times natural log plus x times the derivative of this, which is negative sine x over itself. Multiply both sides by y, so y times the whole thing here, minus x tangent x. But then you need to replace the y with the given function, cosine x raised to the x power. Okay, that's good. Next one, find the integral of cosine of natural log of x over x dx, and e to ln of x, or no, let's make it ln of x plus 1 over x dx, to solve the first one, we use the u sub. U equals natural log of x. Du is 1 over x dx. Don't forget the dx. So the dx over x can be replaced with, so cosine u, and dx over x with du. What's the integral of cosine u? It's sine u. Don't forget the plus c. And then you replace the u with natural log of x. Next one, the same thing with u sub. You take the natural log of x, all of it plus 1 to be u. Du is 1 over x plus 0 dx. So this is the du. It becomes e to the u du. E to the u plus c. E to the ln of x plus c. You can leave it like this, or we know e ln of x is x. So someone is asking, why does the du go away when we do antiderivative step? Why that goes away? Okay, so because when we are, this goes back to way previous sections. When we do integral of a function dx, what is this? From a to b, let's say. This represents the area under the curve from a to b. This is f, a to b, and this is a rectangle. You do dx, the width of the rectangle, and this is f of x. So this is the area of one rectangle. And then what does that saying from a to b? It's saying take all the areas of all the rectangles from x equals a to x equals b and add them up to get the whole area under the curve. So that's what we have here. Now another thing, we have the fundamental theorem of calculus says if you are integrating from a to b f of x dx, this equals capital F of b minus f of a, no more like c or a or dx. And there's a proof for it. If you the book has the entire proof where this came from. And this is very important theorem in calculus. That's what we call the fundamental theorem of calculus. And we call it, some people call it part 1 because there's another part 2, the one that I presented earlier when it comes to finding derivatives. So if you look at the proof, then you will see what happens here, what happens. But it's important also to know what does it mean when you say integral of a function dx. What is dx? Dx is just a slice, small slice. It's that rectangle. The width of that rectangle is very, very small. The dx is really, really small. Next one. Find dy dx if ex squared y equals x squared minus y squared. So now let's look at this one. How do we find the derivative of this? We're going to use implicit differentiation. The derivative of eu is u prime eu equals, the derivative of this is 2x, the derivative of this is 2y prime. Now this one here, this is 2x times y by the product rule and x squared y prime, and we keep this the same. Then we need to solve for y prime, so we distribute 2xy ex squared y plus x squared y prime ex squared y equals 2x minus 2y y prime. Bring the term that has y prime to one side. 2y y prime equals 2x minus 2xy ex squared y. Then factor y prime out. That will give x squared ex squared y plus 2y, and keep this the same. So y prime equals 2x minus 2xy ex squared y over x squared ex squared y plus 2y. Let f of x be a piecewise function, cx cubed minus x, if x less than 3, or 6x plus 2 if x bigger than or equal to 3. Find the value of c if f is continuous. Continuous means continuous everywhere. Okay, so let's go over this one. So in order for a function to be continuous, the limit of the function as x approaches 3, because it's continuous everywhere except we need to check at the 3, that's a joint point, from the right side should equal the limit of the function as x approaches 3 from the left side equals f of 3. Limit as x approaches 3 plus. 3 plus means the second equation. 3 minus the first equation. So now we substitute the 3 in. 6 times 3 plus 2 equals c times 3 to the third minus 3. 18 plus 2 equals 27c minus 3. So 20, add 3 to both sides. So C equals 23 over 27. Is that okay? Another example. We would like to find A and B if f is differentiable. Differentiability means that the derivative of each of these functions at x equals 1, they should be the same. So if you take the derivative of the first function, which is 2ax minus 1, should equal the derivative of the second function at x equals 1. That is, if you substitute 1 here, you get 2a minus 1 equals 3b. That gives me an equation in A and B. Also, we have a theorem that says if a function is differentiable, implies continuous. So differentiability automatically means continuity. So continuous means the limit of the function as x approaches 1 from the right side equals the limit of the function as x approaches 1 from the left side equals f of 1. So from the right side, we choose the second one, so substitute into the second one, b to 1 to the third plus a. From the left side is a 1 square minus 1 plus 5. b plus 8 equals a plus 4. Subtract a on both sides and subtract 8 on both sides. I got another equation. So we have two equations, 2a minus 3b equals 1. Negative a plus b is negative 4. So multiply this by 2. 2a minus 3b is 1. Negative 2a plus 2b is negative 8. Negative b is negative 7. And b is 7. So we got b, and then from the equation negative a plus b equals negative 4, we can substitute that in. Negative a plus 7 equals negative 4. Subtract 7 on both sides, so a equals 11. Find y prime if y equals x cubed times f of x times g of x. Three functions. We are going to see how to find the derivative of such a function. So we can use the product rule first. You can group any of them as one function. Assume these are two as one function. So you have one function here and one function there. Is the derivative of the first one times the second one plus the first one times the derivative of the second one. So y prime equals, derivative of this is 3x squared. Keep this the same. Keep this the same. Here we apply the product rule again. F prime of x times g of x plus f of x times g prime of x. And then y prime equals, keep this the same. This is x cubed f prime of x g of x plus x cubed f of x g prime of x. Next one, good to know, when y prime is bigger than 0, that means the function is increasing. Y prime less than 0 means decreasing. Y double prime bigger than 0, it means concaves up. Concaves up means something like this, it concaves up. Y double prime less than 0 concaves down. Something like this, that concaves down. So find like couple examples or something from the book where you can go over how you sketch functions with some information. They tell you it's increasing from this point to this point, concave up from this point to that point, and so on and so forth. So concavity is good to know. Increasing, decreasing, good to know. Any questions up to this point? Okay, try to integrate this one. X the square root of x plus 3 dx. Okay, so I hope everyone tried. We can do u sub. You take the quantity under the square root to be u. Du is the derivative of x is 1 plus 0, so 1 dx. So this equals, this is the square root of u and this is du. But what happened to that x in the front? You cannot put x here because I want everything to be, I'm transforming everything from x to u, so the new integral will be easier to integrate. So we can't have two variables. So what do we do here? We can solve for x by subtracting 3 on both sides. Then I can put this here. What's the difference between the first one and this one? Is that in the first one, even if you rewrite it as 1/2, as I'm gonna do for this one here, u to the 1/2, you can distribute in the blue one. That first one in blue, you can distribute. So then, but here you can do u times u to the 1/2 minus 3 times u to the 1/2 du. And that would give us u to the 3/2 minus 3u to the 1/2 du. Now it's ready to be integrated. What do we integrate here? So this is u, add 1 to this 5/2 over 5 over 2. Add 1 to this 3/2, 3 over 2 plus c. To simplify those complex fractions, we flip it. 2/5 u to the 5/2. Well, we have a 3 and then flip the 3/2, 2/3 u to the 3/2 plus c. These cancel out. Now replace the u back with the x plus 3 minus 2 x plus 3 to the 3/2 plus c. Any questions about this?